Okay.
What was your question?
So let's talk about one important concept on this, because this is going to be important later on. So I just want to cover this broad topic now, and something known as first ionization energy. So this is going to be important later on. So first ionization energy is how much energy you have to apply to an atom to take away the most loosely held electron. Okay? So here's like a certain analogy. So let's say that I really like Snickers bars, which I do have a fondness for them. Okay? And so, just stay with me for the story. Okay? So, I really like a good Snickers bar, right? And I have one that's really close to me, right?
Yeah.
And so Nathan comes up and tries to take my Snickers bar.
Not a good idea.
You're going to buy my hand. Oh, we'll throw hands, right?
It's okay.
So what's going to happen, the amount of energy is going to take for Nathan to take away that Snickers.
A lot.
A lot, right?
Yeah.
So the more tightly I hold on to that Snickers, the more energy Nathan has to put that in.
Yeah.
Now, scenario number 2, okay? I leave it on the back desk by Kaylee.
I got a head start.
Okay? So I see it, it's there, but I'm a long way from it. It isn't like it's just right here. It's a long way from it. So is Nathan going to have to exert some energy to take it away from it?
Not as much as you.
But not as much, right? So what that means is that if I increase the distance between me and the Snickers bar, the first ionization energy becomes less. Okay, so that you got that. So the farther away something is, the less energy you have to exert to take away that electron. So that's scenario number 1. Now, scenario number 2. Stay with me here. There's a new game that's come out, and to be a winner, you need 8 of these particular game pieces. Okay, Pokemon cards, goats, whatever they are. Okay. Now, there's going to be 3 scenarios. Will has 1 goat. This is how I taught this in Africa. Will has 1 goat. Okay. Isaac has 7 goats.
Dang, you're almost there, kid.
Natalie has 8 goats. Okay.
So Natalie won.
And if you have 8 goats,
Or your hat.
you win. Okay. Now, of the 3, Will, Isaac, or Natalie, if I'm going to take away a goat and I don't want to exert much energy, who's going to be easiest to take a goat from? Will. Why?
He only has 1.
Oh, there's 1
He
goat.
doesn't have much
He
motivation.
doesn't care. He's got a little attraction to it because he has 1 goat. But really, it's like, hey, Burkamp, hey, you want the goat? Take the goat. Okay? Now, what about Isaac?
Isaac? He's
Will he hold on to his goat?
so try to. Because he's about
Yes,
to win.
why?
He's about to win.
He's only 1 goat away. So it would take me more energy to take goats away from Isaac than it would from Will. Now, do you think Isaac and Will might form a coalition? Why? To get 8. So when Will comes up to Isaac and says, dude, hey, I got 1 goat. Okay. So now you all have formed an ionic goat bond. Because if you've given up the goat, you've taken it in.
No.
Will is like which group of elements?
Reject
Alkaline.
error.
Yeah, he's like the alkali goats.
Yeah.
Okay? What about Isaac?
He's a, what's the one? Halogen.
He's the Howl goats.
I like that.
Yeah.
Oh, good. There we
I'm
go.
the
So
noble
Isaac is the Howl goats. Now, Natalie has 8, so she's the noble.
Go.
She's the noble goat.
She's a double goat.
Okay?
Go. She's empty. There we go.
So we have the alpha goats, the Howl goats, and the noble goats. So,
Boom, boom, boom.
why is it going to take me the most energy to get a goat away from Natalie.
Because she's the goat. She
I
already won.
care about
The
this.
She has all 8
LeBron
goats,
James.
Yeah.
right?
She has all the
So she's going to really hold on to the goats that she has. Now, is Natalie going to form a bond with either Isaac or Will?
No.
She looks down upon him.
Why not?
She already
She's
won.
noble.
I don't
She has
think
8
so.
goats. She's the noble goat. Okay? So since she's the noble goat, she's like, peasants, go away. I have my 8 goats, go away. But Will and Isaac will form a bond. Okay? Now, when you look at first ionization energy, there's 2 things that play a part in this. Number 1, how close are they to the noble goat arrangement? Okay? If they're far away from the noble goat arrangement like Will is, hey, it's easy to take away a goat. If they're close to being like how goats, hey, pretty tight. Gonna hold on to them. If you have the noble goat arrangement, that's gonna be the most energy to take that away.
Sorry. We were talking about goats.
Hot goat yoga. Now, the other contributing factor, and this is what's known as Coulomb's law, is this equation. F equals KQ1 Q2 over distance squared.
Get out.
Okay?
Get out.
So
We're not doing this.
these are the charges on the goats or the protons that are at the center. And this is how far away the goats are from the center. Okay? So let's look at Will. So we could have lithium goat Will, which is 1s2, 2s1. Or we could have potassium goat Will, which is like 1s2, 2s2, all this stuff, and then he's well out here at 4s1. Okay? So knowing that, what's going to have the higher first ionization energy? Lithium or potassium?
Lithium.
Because you have 2 things.
It's closer.
It's closer, right? Now, the potassium technically has more protons to pull on the electron. Okay, potassium does have more protons pulling on that 1 electron out there. But you're dividing by distance squared. So the distance squared is more of a factor than the increasing number of protons. So, knowing that, let's talk about that first question. It says, which of the following ground state electron configurations represent the atom that has the lowest first ionization energy? So what are you going to look for?
Look for distance.
Farthest one to the left and down.
Huh?
Real wide.
It's to the right and down.
Brother, if it's to the right where Natalie is, she ain't want to change. She's good.
Wait.
You got Bill over here all the way far left, and he's like, damn, I hate my wife. So he wants to change pronto. Oh, I think you're flipping. Left.
We basically just want.
Ah!
It's like reality TV, bro.
So,
I feel like I should like.
to have a
Yes, all right.
To have a low first ionization energy, does that mean it's easy to take away the goat or difficult to take away the goat?
Easy.
Easy.
So obviously make it wrong, and it's
And it's what?
That's literally what they
It's D.
It is D.
This is how it's
Okay? It is D.
Order the coin.
Now, knowing that, now you have the question about the fluoride ion. So the ground state electron configuration of the fluoride ion. How many goats does fluorine have? How many does it want? 8. So now on the test on the periodic table that you're all going to have, you just have the periodic table. You don't have numbers off to the left that indicate that highest occupied energy level. But what you could do, if I were you all,
draw them.
I would just write them in. Okay, so you were trying to find the fluoride ion. What's the number? What row is fluorine in?
2.
So what are you? Which energy level are you filling?
2.
The second one. Okay. So which one is filling up the second energy level?
C.
C.
It's F minus.
Wait, what is gross?
Because it wants a fluoride F1 minus, so it wants to gain a goat. So what's the difference between B and C?
B is like the actual element.
Yeah, B is the fluoride element because it has an equal number of protons and electrons. So C, you've gained a goat. Okay?
Berg, I missed that.
I know, that's why we're talking about that. Okay, on the back side, you have one more question. First of all, best represents the ground state electron configuration from the element of selenium. Now, there's a long way to do this and a short way to do this. Okay?
34.
So, go down, find selenium.
It's right there next to
Which row is selenium in?
Number 4.
So, right away, what's going to be your highest occupied energy level?
4's A and B are out.
The fourth. So, that eliminates A and B. Okay? Can't be that. So that leaves you C or D. Now, here you are in that p sublot. How many electrons can you put into a p orbital? 6. So if you count across 1, 2, 3, 4, 5, 6. The noble ghosts have 6 p electrons. So find selenium. Which row across are you? The 4th or the 5th?
4.
So what's your correct answer?
C.
Wait. You can only put 2. You can put 6. I think you can only put 2 on like the orbital. There's 2 orbitals.
There's 3
Yeah,
orbitals.
So you can only put 2 electrons per orbital.
Yes. Total was 6.
Total 6.
Okay, so stop that.